Now we're going to take a look at the rest of the solar system fairly quickly. There are lots of objects here, but we're not going to spend a whole lot of time detailing them. So we'll start with asteroids. Thousands of these things have been discovered. The first asteroid was discovered right at the start of the 1800s, and it's still the largest asteroid discovered. We'll show you a picture of it here pretty soon. These are small, rocky, and metallic. They are not the remains of a destroyed planet. They're leftovers from the formation of the solar system. Jupiter's gravity helps to keep them stirred up, preventing their coalescing into a single object. But if we could combine all of them into one object, it would be an object with less than 4% of the mass of Earth's moon. Most of the asteroids orbit between Mars and Jupiter in the asteroid belt, although there are a lot of them elsewhere in the solar system. I'll show you a plot that'll give you an idea of how widely spread they are. Some of them are on orbits that cross Earth's orbit occasionally. We want to start keeping an eye on those things. They can cause problems. They're the oldest rocks in the solar system, typically 4.56 billion years old. They effectively allow us to date the solar system by dating the rocks that are in there using radioactive dating techniques. This picture was taken by the Galileo spacecraft in 1991 while it was on its way to Jupiter. The Galileo spacecraft orbited Jupiter for quite a few years and then eventually was crashed into the planet, somewhat like the Cassini spacecraft was crashed into Saturn. Note the odd shape. Few asteroids have enough mass to form a spherical shape. This is asteroid Gaspra, by the way. This picture was taken by the NEAR spacecraft, which crash-landed deliberately on this asteroid in 2001. It wasn't a very hard crash. They were using the gravity of the asteroid to pull in the spacecraft, and it's pretty weak gravity, so it was just going out there very gently. This is 253 Matilda, or something like that. I'm not sure just how this one would be pronounced. It's about 50 kilometers across. And here's our largest asteroid. Looks kind of like a gibbous moon right now, but this is Ceres, and it accounts for 1/3 of the mass of the entire asteroid belt. But its mass is still only 1.4% the mass of Earth's moon. The bright spots on it are sunlight reflecting off of salt deposits, but not just table salt. If you take a chemistry class, you'll learn about other types of salts that you can have. And this photo was taken by the Dawn spacecraft, which is in orbit around Ceres and has been since 2015. Although it ran out of fuel in 2018 and so isn't able to control itself anymore, but it'll probably just keep orbiting around that thing for ages and ages. So where are the asteroids? Check out these plots of current positions of planets and asteroids as of June 5th, 2021. This is the inner solar system. Mercury's orbit is that inner circle, and Mars' orbit is that outer faint blue circle. It's easy to lose Mars' orbit as you get up close to the top of this thing. The red circles, both the filled and empty ones, have perihelia closer than about 1.3 AU. And perihelion is the closest approach to the sun. So that means their closest points to the sun is closer than Mars' orbit. You can see Earth's orbit on there. I can light that up so you can see it better. Whoops, it's a red pointer. That'll make it tough to see, but Earth's orbit, I'm kind of circling around it right now. Should have come up with a different way of doing that, but that's Earth's orbit. And there are an awful lot of asteroids that are inside and outside Earth's orbit. They're sometimes called near-Earth asteroids, especially the ones that cross our orbit. Here's the farther out part of the solar system. This still only goes out to Jupiter's orbit. Mars' orbit is right there, and Jupiter's orbit is this outer circle here. and you can see there are a lot of asteroids between Mars and Jupiter's orbit. By the way, in order to see these asteroids on here, they had to make the dots for them much larger than they actually are. The average asteroid is not that big. The average distance between them is on the order of 1,000,000 kilometers or 600,000 miles, 2.5 times the Earth-Moon distance anyway. They are widely separated. The green circles on here are minor planets with perihelia greater than Mars orbit. By the way, there are asteroids. Jupiter, if I tracked it down on here, is actually right down here at the time of this plot. And there's a group of asteroids that orbit in front of Jupiter by about 60 degrees if you measure an angle from the Sun to those asteroids and the Sun to Jupiter. And then there are some that lag behind Jupiter by 60 degrees as well. And those are actually Lagrange points in the orbit. They're fairly stable places. But those asteroids that lead and follow Jupiter by 60 degrees are called Trojan asteroids. The Earth actually has at least one Trojan asteroid that leads us by 60 degrees in our orbit. And Saturn has some. I think we've discovered some for Neptune as well. I'm not sure about Uranus. They're harder to spot the farther out they are because they're small and they are only seen by reflected light. So they're difficult to study after a while. This is something I just downloaded today. Running tallies. Near-Earth object discovered. Okay, those are the asteroids that are close to Earth. This month, 143. This year, 715. All time, 28,640. There's quite an effort to determine the orbits of all the near-Earth objects carefully. Some of those near-Earth objects could cause problems if they happen to smack into the Earth. A few years ago, there was a not too large asteroid that entered the Earth over Chelyabinsk, Russia, and thousands of people were injured by mostly breaking glass from the shock wave of the thing coming through the atmosphere. Minor planets discovered. I got this off the Minor Planet Center. They call asteroids minor planets there instead of asteroids. So this month, 145. This year, 757 discovered. And all time, 1,165,954. So there are a lot of asteroids. And then there's some comets down there this year too. Most comets aren't particularly spectacular. Every once in a while we get a good one, but not always. Oh, playing tag with an asteroid. I'm going to have to resort to some different tricks to get this to work, but this is from October 2020. A NASA spacecraft, OSIRIS-REx, briefly touched near-Earth asteroid Bennu and grabbed a small sample of material for return to Earth, scheduled for September 2023. You can see what OSIRIS-REx is short for. NASA has this way of coming up with just these crazy names for things and then somehow jumbling the words to make them into something that sounds kind of cool. But the sample they gathered was only about 60 grams of material. Still, it would be kind of neat to study that stuff from an asteroid and see just what it's made of. Okay, you saw the sample mission, at least about 48 seconds worth of it, and it touched the thing with its probe and stuff flew all over. The material on an asteroid is not very tightly held to it. The gravity is extremely weak, so you kick up stuff, a little cloud of dust, and it'll take quite a while to settle back down onto the asteroid. The speed at impact was less than 4 inches per second, so not very fast, and it still stirred up quite a cloud of dust. Okay, other solar system objects, comets. And a common phrase that's used to describe comets is dirty snowballs, as long as you let snow include ices of other things, not just water, like CO2, probably carbon monoxide too, CH4, that's methane, NH3 is ammonia. You get it cold enough, it becomes a snow or a solid. So lots of stuff like that. The comets that visit the inner solar system usually have very elongated orbits. Their tails form as they approach the sun. The reason the tails form is as they move to the inner solar system, the ices evaporate, get heated up and evaporate, come off of the comet nucleus, and carry away some of the dirt that's in the comet with it, the dust and dirt. The solar wind, which is a constant outpouring of material from the sun, blows that material away from the comet, and the tail always points away from the sun on both approach to and movement away from the sun. That's something kind of interesting about comet tails. We can sort comets into two major categories, but before we do that, let's look at just a few pretty pictures of some spectacular recent comets. This was Comet Hale-Bopp in 1997. The year before Comet Hale-Bopp was Comet Hyakutake, 1996. When I saw Hyakutake, I thought that was it. That was the most spectacular comet I'd ever see. And then the next year, Hale-Bopp came by and actually was more spectacular still. A not quite so spectacular comet for us in the northern hemisphere was Comet McNaught, which was visible in January 2007. And the only time you could see it here was shortly after sunset. You had to look out to the western sky, and I had to use binoculars to see it. When I looked, I could just barely see it. It was pretty tough to see, but when it got down to the southern hemisphere, this is a picture taken from New Zealand, it was bright enough to be seen from the cities down there, so it was pretty spectacular. It was as spectacular as Hale-Bopp or Hyakutake had been here. Now, the categories we sort these things into are short period comets, and those are those with periods less than about 200 years, and the upper limit is somewhat arbitrary and not very tightly nailed down. Figure 200 years plus or minus a bunch. They tend to orbit in the same direction as the planets. Their orbits lie within 30 degrees of the Earth's orbital plane, and about 100 have been discovered so far. Probably the most famous short period comet is Comet Halley, and interestingly enough, it orbits in the direction opposite the planets, but blame Jupiter on that. It used to orbit in the same direction as the planets, and on some previous visit to the inner solar system, Jupiter's gravity grabbed it and flung it in the opposite direction. So it didn't get captured by Jupiter, just flung. Long period comets, their orbital periods are longer than 200 years and usually way longer than 200 years, like thousands of years. They don't have any common tendency for their orbital directions. They don't have any common tendency for their orbital planes, so they don't stay close to the plane of the ecliptic or the planet planes at all. Hundreds of these have been well studied. Many more have been discovered, and some famous recent ones are the three that I showed you pictures of: Hyakutake, Hale-Bopp, and McNaught. Both Hyakutake and Hale-Bopp came up from well south of the plane of the planets. If you were standing in Antarctica looking straight up, they came from that direction in the sky. They just visited the inner solar system, came up a little ways above the sun, and then just dove back down again. At one time, I think the estimate was that Hyakutake hadn't been to the inner solar system for 14,000 years, which is quite a while. But its orbit got tweaked on this orbit, and it won't be that many years before it comes back. Comet orbits vary quite a bit, because if they pass close to the planets, they can get changed. The off-gassing they do while they're traveling because of that evaporating material can affect their orbits and all sorts of things. They're not quite as stable as planets. They're also not as massive, so it's easier to deflect them.